Rachel, I'm your TA, and I'm going to walk you through the sample prep for the GC lab. So when you first come in, you're going to get ready like you usually do for lab, and each of you will have your own station. You'll be working within your groups, and each of you will be doing one rep of one oil for each analysis, but you will all have your own individual stations with everything you need to do the sample prep. So if you look here, we have our pasture pipettes in the box with the dropper. You have chem wipes, our oil sample, so each station will have a different oil sample. This one is E. And then you'll have a glass screw cap tube, and then over here you will have sodium sulfate with a spatula and a little 7 milliliter I'll edit it out, a 7 milliliter screw cap vial, and then you have your GC vial, and this is for the auto sampler to put your sample in at the end, but we'll get there. So to start, I'm going to walk you through the preparation. The first thing you're going to do is put 2 drops of oil into your glass tube. And since I am doing oil E, I am going to label my tube with an E on it. This way, if we have multiple tubes in the water bath, then we won't get them mixed up between person to person, and we know exactly which sample is what. So now we will put 2 drops of oil into our tube, and so we call this semi-quantitative data. And the reason that we call it semi-quantitative data is because we are not adding a known volume or measuring our volume of the oil that we are putting into our tube for the analysis. We could help to make this more quantitative by weighing the oil that we are putting in, but for the sake of identifying the oils, we are going to use a semi-quantitative approach. So when we're adding the oil in, you don't want to hold your dropper just like this above it, because it could get on the sides or it could drop over here. And for the steps that we have coming up, we want to be able to get those 2 drops all the way at the bottom. So I'm going to put my dropper down there and put 2 drops at the bottom, and then carefully pull it out, and I'm going to cap my tubes. There will be this beaker here for you to dispose of your pasture pipettes into, and then we'll put those all in the glass disposal at the end. So now that you have added the oil into your tube, you're going to bring it over here to this station, and it's marked methanolic sodium hydroxide, and your addendum tells you to add 4 milliliters. So I've written it on here, and it's also written on the burette. So I'm going to add 4 milliliters of my methanolic sodium hydroxide. The first step of adding your methanolic sodium hydroxide is the step that induces saponification, and what it does is it cleaves the glycerol backbone off of your fatty acids. So I'm going to bring my volume all the way up to the 5, or the 0 I suppose, and then I'm only going to dispense 4 milliliters. You want to be very careful not to touch the tip of your pipette onto your tube, or you will contaminate the burette for the rest of everybody that needs to use it. So I'm going to hold it above and carefully dispense down 4 milliliters, and then I'll dispense the rest back into my reagent bottle and close both of them. And now I'm going to vortex your cap really tight, just to make sure that we don't release any of the methanolic sodium hydroxide when we go to our water bath, and also for vortexing purposes. So we're going to vortex it really So you're now going to put your sample into your water bath for 10 minutes. And the combination of the methanolic sodium hydroxide and the heat helps to catalyze that saponification reaction to relieve your fatty acids from the glycerol backbone so that we can quantify them, and also so that it makes them more volatile for GC analysis. So after your 10 minutes in the water bath, you're going to come over and take your sample out. It's very important that you use a hot hand to take out your sample so that you don't burn yourself, because it's really, really hot. So you're going to carefully remove it. And then we're going to right away take it over to the sink so that we can rinse it under water. So you're going to want to start by running your tube under warm water and then slowly move it over to cold water so that you don't shock your tube and break it. You want to really ensure that your tube is at room temperature and not warm by testing it on the back of your gloved hand before you go on to the next step. So next, you're going to add your boron trifluoride, and that is going to be over here in the hood, and we have a specific volumetric pipette with it labeled for boron trifluoride, and it tells you to use 4 milliliters, and it also tells you on the bottle, so you cannot mix it up, you gotta use 4 milliliters. So I'm going to, again, like we did for the methanoic sodium hydroxide, fill it all the way up to the 0 mark, and then dispense down 4 milliliters. And again, I'm not going to touch the tip of my dispenser to my tube so that I don't contaminate it. So I will hold it above and release down 4 milliliters. Now again, I'm going to put my cap on my tube very tightly, and I'm going to vortex it. Now you're going to make sure that the cap on your tube is very tight, and you're going to put it back into the water bath for 10 minutes. When you're using the water bath, there is a rack inside of it that you can place your tube into using your hot hand so that you don't have to take that rack in and out when you're using it. And you can just use the rack that's at your station to move your tube from one station to another. Incubation with the boron trifluoride for 10 minutes is going to help promote methylation of your fatty acids, which is going to make your fatty acids more volatile, but also more thermally stable for your GC analysis and less polar. So now it's been 10 minutes, and I'm going to again use the hot hand to pull my tube out of the water bath. Now I'm going to take it over to the sink, and we're going to rinse it again with the cold water, or the warm and then cold water, so that we can bring down the temperature of our tube before we move on to the next. So again, I'm just starting with warm water and then moving over to cold water to rinse my tube, and I'm going up and down to make sure that I'm getting it all cooled off. And I will again test it on the back of my hand to make sure it is at room temperature before I move on to the next. So now that my tube is cooled with my sample in it, I'm going to bring it back over to the hood where we did the boron trifluoride, and I'm going to add 7 milliliters of my hexane and 7 milliliters of the saturated sodium chloride solution. You can see that we have volumetric pipettes that have the same exact color and tell you exactly what these need to be used for. So don't interchange them, because then you'll contaminate our solutions. So now I'm going to add 7 milliliters to my tube of the hexane, the same way that we did before, by bringing my solution all the way up to the 0 and then dispensing down to the 7. Again, I'm not touching my tube so that I do not contaminate my volumetric pipette. Next, I'm going to add my saturated sodium chloride solution in the same manner. Now I'm going to cap my tube very tightly and take it back to my station. Now at my station, I'm going to shake my solution with the cap very tight by hand for 5 minutes. So when we added the hexane solution, we are adding that so that our fatty acids are very, very soluble in the hexane solution. And then we add our saturated sodium chloride solution to increase the ionic strength of our solution, and help to push the fatty acids into the hexane solution so that we can extract all of the hexanes or all of the fatty acids into the hexane for the next step. After we have shaken it now for 5 minutes, we're going to let it sit, and you're going to let it separate for 5 more minutes. And you can see that we've already started to get 2 layers in our solution, and it's starting to separate. So we're going to let it sit for 5 minutes. So now I've let it separate for 5 minutes, and I am going to take just 1.5 approximately milliliters of my top hexane section, and I'm going to put it into my 7 milliliter glass screw cap. And when I'm doing this, I'm going to use my pasture pipette, so that's why I said it's going to be approximately 1.5 milliliters, because we're not going to measure it. And when I'm doing this, I'm going to make sure that I am not touching my pasture pipette to the sides or down into the second layer of my sample, so that I don't contaminate it or pull up any of the parts that we don't want in our sample.
Okay, and then this for the sodium acetate.
Now I'm going to add my sodium sulfate into my hexane solution that I've put into the 7 milliliter vial. And to do this, I'm just going to take a spatula full, and it helps if you kind of tip your vial and then slowly put it in there. And I spilt a little bit, so I'm going to add a little bit more into my solution. Now I'm going to cap my vial very tightly, and I'm going to swirl my solution around. If you see that your sodium sulfate has clumped at the bottom and you don't see any particles kind of freely flowing, that means you need to add a little bit more of your sodium sulfate, because what your sodium sulfate is doing is taking out any moisture that is in your sample so that we can run it on the GC. So if it clumps, that tells you that there is moisture, and you need to add more until you see some free-flowing particles in your sample when you swirl it, to let you know that it is now completely dehydrated. So now we are going to transfer our sample into the GC Auto Sampler vial. And I'm going to label this with my last name and the oil that I did. So oil E with my Sharpie. Now I'm going to take a pasture pipette again, a new one, and I am going to add my sample into my auto sampler vial. And you want to have it at least up to the 1.5 milliliter mark on your sample vial, so that we have enough in there that the GC can pull, the syringe can pull the sample out. And again, I'm not going to go down there and touch my sodium sulfate that's at the bottom or pick up any of those particles. Now I can cap my tube, and it is ready for GC analysis of your fatty acid. You'll again dispose of your pipette, and then you will take your vial up to the front where we are collecting them, and we will run all of your samples together.